everyone. Sorry for the slight delay. That was totally my fault. We rescheduled this event, and so I gave Lisa the wrong StreamYard link. So we were all over on a dead event page that was set up for 2 weeks ago. So thank you, everybody, for your patience. Lisa, I'm sorry for the bumpy start, but the good news is we're now all here and we're all ready to go. So thank you everybody for joining us for this highly anticipated 5th installment of Lisa's Beginner's Crash Course series. If you have not already viewed parts 1 through 4, really encourage you to check them out. They've been really popular. And yeah, so as always, we're super happy and fortunate to have Lisa with us today. She's a developer advocate here at Elastic. I have the pleasure of working closely with her. And without further ado, Lisa, I'll hand things over to you after one quick announcement. If you guys have questions that come up throughout the presentation, please put them in the chat. I'm going to be compiling those as Lisa goes through the presentation. And towards the end, if there's time, Lisa will address some of your questions. But if there's not time, then she's agreed generously to review those questions and get some answers for you in the Git repo for part 5 of the series, which I can share a link to shortly. So without further ado, Lisa, I'll hand things over to you.
Awesome. Thank you so much, Faith. She really saved the day with our streaming. So hi, everybody. Welcome to the Beginner's Crash Course to Elasticstack. Again, my name is Lisa, and I'm a developer advocate at Elastic. So today, we're covering part 5 of the Beginner's Crash Course series. So for those of you who are joining us for the first time, this is a series of workshops for developers, and it's geared towards beginners who want to get started with the Elasticstack. So the stack is made up of 4 products: Beats, Logstash, Elasticsearch, and Kibana. And with the stack, you can take data from any source in any format, then search, analyze, and visualize in real time. So throughout the series, we've been focusing on Elasticsearch and Kibana. So far, we learned about how Elasticsearch and Kibana works and how you can use these products to fine-tune the relevance of your search and run full text search as well as aggregations. And today we'll be going over mapping, and this topic pulls together a lot of the concepts we've learned during the series. So mapping defines how a document and its fields are indexed and stored. And because of that, it affects how Elasticsearch stores and searches for data. So learning how to define your own mapping is really useful because it helps you optimize the performance of Elasticsearch and save disk space as well. Now, when you hear about mapping for the first time, it may sound really abstract. So we'll break it down to bite-sized pieces to really understand this concept. Now, the best way to explain how mapping works is by showing you through Elasticsearch and Kibana. And in order to follow along, we need to do some prerequisite work. So first, we need to set up and run Elasticsearch and Kibana. Then we'll have 2 windows open side by side. One window will display the Kibana console, also known as DevTools, and the other window will have the Part 5 repo. So we covered how to complete step 1 in a previous workshop. So to complete step 1, go to the link shown here. So Faith will be dropping this link in the chat as we speak. So when you click on this link, it'll take you to the table of contents for Beginner's Crash Course. So for those of you who are new, I create a GitHub repo for each workshop. And these repos contain all the resources shared during the workshop, including the presentation slides and the recording. Now, this link includes a table of contents for all repos shared during the series. So to complete step 1, click on part 2. And when you get there, scroll down to the resources section and click on the video of the workshop. Now you'll watch the video from timestamp 1428 to 19, and this section will show you how to set up Elasticsearch and Kibana and take you to the Kibana homepage. So all you have to do is to click on DevTools option and have it pulled up in one window. And once you do that, go back to the table of contents, then pull up part 5 repo in another window. Okay, so let's get organized here real quick. All right. So I have 2 windows open. On the left, I have the Kibana console, and on the right, I have the part 5 repo. So the Kibana console is split into 2 panels. The left panel is where you send requests to Elasticsearch, and the right panel shows you the response from Elasticsearch. And for the rest of the workshop, we'll be sending requests from Kibana to Elasticsearch to view and customize the mapping. Okay, so let's take a look at part 5 repo on the right, which contains all the resources that are shared during the workshop. So let's zoom out and focus on the big picture real quick. So imagine that you're building an app that requires you to store and search data. And naturally, you want to store data using the smallest disk space while maximizing your search performance. And that is where mapping comes in, which defines how a document and its fields are indexed and stored. And it does that by defining field types. And depending on its field type, the fields are stored and indexed accordingly. So before we delve into mapping, let's review a few concepts. So throughout the series, we learned how to query and aggregate data to get insights. But before we could run queries or aggregations, we had to add data to Elasticsearch first. So in Elasticsearch, data is stored as documents. And a document is a JSON object that contains whatever data you want to store in Elasticsearch. And a document looks something like this. So in a JSON object, it contains a list of fields or key value pairs. So let's say we are creating an app for produce warehouse, and you want to store data about produce so you can search for it. And each document contains information about a produce item. So for example, this one has fields called name, botanical name, produce type, and etc. And you'll see that each field is of a different JSON data type. So for example, the field name JSON data type is a string. For the field quantity, the type is an integer. And you even see type Boolean here as well. So let's say that we want to index this document. So for all requests we'll go over, I included a syntax for you, so you could customize this for your own use case. But for our tutorial, we'll use a request shown below the example. Now to index a document, we start our request with post, followed by name of the index that we want to index documents into, then the document endpoint, followed by a JSON object with whatever you want to store in Elasticsearch. Now we're naming our index temp index. So let's copy and paste that into the console. Make sure to select and send. All right. Now you'll see that the temp index has been successfully created and this document has been indexed. Now, what we have covered so far is a review from previous workshops. And what we haven't covered yet is what actually goes behind the scenes when you index a document. And you guessed it, this is where mapping comes into play. So remember, mapping defines how a document and its fields are indexed and stored. And it does that by defining the type of each field. So mapping looks something like this. So think of it as an Elasticsearch data schema. So it contains a list of names and types of fields in an index. And depending on its type, each field is indexed and stored differently in Elasticsearch. So mapping plays an important role in how Elasticsearch stores and searches for data. Okay, so let's go back to the request that we sent earlier. So this request asks Elasticsearch to create a new index called temp index. and index this document into it. But wait a minute, mapping determines how a document and its fields should be indexed and stored, but we didn't define the mapping ahead of time. So how did this document get indexed? Well, when a user doesn't define mapping in advance, Elasticsearch creates or updates the mapping by default. This is known as dynamic mapping. So let's check out this diagram here. So we ask Elasticsearch, hey, create an index called temp index and put this document into it. And then Elasticsearch says, all right, you got it. But then it realizes that the mapping has not been defined for the temp index. So here we have a document we just indexed. So what Elasticsearch does is it looks at each field of the document, then tries to infer the data type from the field content. Then it will assign a type to each field. So for example, here, Elasticsearch is looking at the field quantity and sees that it's a JSON type integer. So it assigns a field type long to this field. And once Elasticsearch does this for every field in a document, it creates a list of all field names and types known as mapping. And depending on the assigned field type, each field of the document is indexed and primed for different types of requests. So let's take a look at the mapping that Elasticsearch created for us. And to do so, you send the following requests. So you start with get, followed by name of the index, whose mapping that you want to view, then the mapping endpoint. So let's copy and paste this request into the console. Make sure to select and send. Then Elasticsearch will return the mapping of temp index. Now, if you look under properties, it lists all the fields of the document we just indexed in an alphabetical order. So for example, you see the field botanical name, country of origin, and etc. Right? Now, if you look at each field, it lists the type of each field. For example, the field country of origin has been typed as text and keyword. Date purchased has been typed as date. And the field quantity has been typed as long, unit price as float. Now, these are only the few of many field types that are recognized by Elasticsearch. So if you're interested in the list of all field types, you can click here. Okay, so at a first glance, the mapping looks really complicated, but we're going to break this down. And depending on what your use case is, the mapping can be customized to make storage and indexing more efficient. Now, we'll spend the rest of the workshop talking about what type of mapping is best for different types of requests. Then we'll learn how to define our own mapping. Okay, so let's take a look at our document again. And you'll see that a lot of these fields, such as botanical name, produce type, and country of origin, contain strings. Now, if we examine the type of these string fields, for example, if you look at botanical name, you'll see that this field has been mapped as both text and keyword by default. Now, text and keyword are two kinds of string data types, and by default, every string field gets mapped twice as a text field and as a keyword multi-field. And each field type is primed for different types of requests. So let's go over the difference between the two. So the text field type is designed for full text searches. And one of the benefits of full text search is that you could search for individual search terms in a non-case sensitive manner. Whereas keyword is designed for exact searches, aggregations, and sorting. So this is useful when you're searching for original strings. And depending on what type of requests you want to run on each field, you can assign the type as either text, keyword, or both, right? So let's go back to our mapping. And if you look at the field description, you'll see that it has been mapped twice as text and keyword, right? So let's focus on text first, right? Now, when the field is mapped as text, the content of the field passes through an analyzer. So let's take a look at the field description in our document and focus on this last sentence here. These pineapples are sourced from New Zealand. Now, when this string is analyzed, it's broken up into individual words, also known as tokens. And notice that the analyzer lowercases each token and it removes the punctuation. Now, this process is known as text analysis. Right? So let's step back for a second. So here we're asking Elasticsearch to index the following document with a field description. And we want to assign this document an ID of 1. Now, Elasticsearch will look at the field and see that it's a string. So it'll map this field both as text and keyword. Now, when the field is mapped as text, the string passes through the analyzer. And once the string is analyzed, these individual tokens are stored in a sorted list called inverted index. And in an inverted index, each unique token is stored along with its associated doc ID. Now, the same process occurs every time you index a new document. So for example, let's say we index a new document with identical content as document 1, but we gave this document an ID of 2. So this will go through the same process where it's split into individual tokens. But if these tokens already exist in the inverted index, only the document IDs are updated. Now, if we add another document with an ID of 3 with one new token here, then the new token is added to the index, and also the doc IDs are updated for existing tokens. Now, this is what happens in the background when you index fields that are typed as text. Now, the fields that are assigned as typed text are optimal for full text search. So let's take a look at this diagram here. The client is asking to fetch all documents containing the terms New or Zealand. Now, when this request is sent, Elasticsearch doesn't read through every document for the search terms. It just goes straight to the inverted index, looks up the search terms, then finds a matching document IDs and sends them back to the user. So inverted index is the reason why Elasticsearch is able to search really fast. And since all the terms in the inverted index are lowercase, you could search for things in a non-case sensitive manner and still get the same results. Okay, so let's do another review. So here we're indexing 3 documents. Each has a field country with a string value. And by default, the field country is mapped twice as text and keyword. Now, the text fields are analyzed and tokens are stored in an inverted index. And this is great for full text search, but it's not optimized for performing aggregation, sorting, or exact searches. For these types of requests, Elasticsearch depends on the keyword field. Now, when a keyword field is created, the content of the field is not analyzed and is not stored in an inverted index. Instead, it uses a data structure called doc values to store data. So let's zoom in on the table here. Okay. So for each document, the document ID along with the field value, the original string, are added to a table. Now, this data structure called doc values is optimal for aggregation, sorting, or exact searches. So if you're planning on performing any of these requests on a string field, you'll want to map this field as keyword type. Now, when Elasticsearch dynamically creates a mapping for you, it doesn't know what you want to use a string for. So to be on the safe side, it maps all strings to both field types, but you don't always need both. So in that case, the default setting is wasteful because it slows down indexing and takes up more disk space. So defining our own mapping could help us store and search data more efficiently. Now, defining our own mapping takes more planning because we need to decide what type of requests we want to run on these fields. So we could designate which fields will be only full text searchable, or only be used in aggregation, or be able to support both options. So, all right, now that we understand the field types, text and keyword, let's go over how we can optimize our mapping. So to do that, we're going to do a little exercise. So imagine you're building an app for a produce warehouse, and our client wants to be able to search for produce name, country of origin, and description, identify top countries of origin with the most frequent purchase history, sort produce by produce type, and get the summary of monthly expense. Now, this is a sample document that our client gave us that closely resembles the data set. Now, I'm going to delete everything in my console right now. And I'm going to copy this document here as a reference. So we're going to go through each feature and figure out the optimal mapping. Okay, so the first feature allows a user to search for produce name, country of origin, and description. So we know that it'll involve the field name, country of origin, and description. And all of these fields contain strings, which means that by default, these will get mapped twice as text and keyword. So let's say if we need both field types. Now, our client wants to be able to search on these fields, but it's unlikely that the user will send search terms that are exactly the way it's written in our documents. So the user should be able to run a search for individual terms in a non-case sensitive manner, which means that the field name, country of origin, and description should be full text searchable. Now, let's say our client doesn't want to run aggregation, sorting, or exact searches on the fields name and description. So for these fields, we do not need the keyword type. So to avoid mapping these fields twice, we'll specify that we only want the type text. Right? Now, at this point, we don't know if the field country of origin should be only full text searchable. So let's leave that for now. Okay. Now, if you look at the second feature, the user should be able to identify top countries of origin with the most frequent purchase history. So this involves the field country of origin. And for this type of request, we need to run terms aggregations on this field, which means that we need a keyword field. And since we need to perform full text search and aggregations on this field, we'll map this field twice as text and keyword. Okay, now let's look at the third feature. So the user should be able to sort produce by produce type. And this feature involves the field produce type, which contains a string. And this obviously involves sorting, so we need a keyword type. And let's say the client doesn't want to run full text search for this field. So we need to map this field as keyword type only. Now, the fourth feature is that the user should be able to get the summary of monthly expense. So this feature involves the fields day purchased, quantity, and unit price. So let's break this down. So this requires splitting data into monthly buckets, then adding up the total of each document in the bucket. So the next diagram shows you the April bucket, and the documents of all produce purchased during April are included here. Now let's zoom in on one of the documents to look at its fields. Now this document is the same document as the one that I pasted here. Now you'll notice that our document doesn't have a field called total. However, we do have the fields called quantity and unit price. So to get the total for each document, we need to multiply quantity by unit price, then add up the total of all documents in each bucket, and this will yield the monthly expense. So here we have the summary of optimal mapping for string fields that we just discussed. And for the last feature, we need to calculate the total for each produce, so it can be used to calculate the monthly expense. Now, after going through each feature, we know that the string field botanical name and object vendor details are not used. And since we don't need the inverted index or the doc values of these fields, we're going to disable them, right? So this should help us save disk space and minimize the number of fields in the mapping. Okay, so now that we thought through the optimal mapping, let's define our own. And there are a few rules that about mapping that you need to know. And I'm going to show you how these rules work through the exercise we're about to do. All right, so let's go over the rules real quick. As you remember, you can index documents without defining mapping ahead of time. And that's because by default, Elasticsearch creates a mapping for you if it doesn't exist. Now, if you do decide to define your own mapping, you could do so at index creation. Now remember, there's only one mapping defined per index. So once the index has been created, you could only add new fields to a mapping, but we can't change a mapping of an existing field. Now, if you must change a type of an existing field, you have to create a new index with the desired mapping, then reindex all documents into the new index. Okay, so let's see how these rules work. So first, what you need to do is to index a sample document into a test index. Now, this is the same document that our client provided for us. As you can see, this is identical to the document we examined earlier. Now, the sample must contain all the fields that you want to define, and these fields should contain values of field types that you want. So for example, if you want the unit price to be in decimals, then the sample field should contain decimals and not an integer, right? So we'll index this document by sending the following request, which is post followed by name of the index that you want to add this document to, then a document endpoint, then the document. So I'm going to delete everything from my console here and copy and paste this request. I'm going to make sure to select and send. Okay, so it looks like the test index was successfully created and the document was indexed just fine. And when we're creating this index, we didn't define a mapping for it. So according to the rules, Elasticsearch should have created one for us. So let's check the mapping. To view the mapping, we'll say get the mapping of test index. So let's copy and paste that into the console. Oops. Make sure select and send. Now, Elasticsearch will show you the mapping it created. Now, the point of doing these first two steps is to see how Elasticsearch maps this document. So we can use the mapping as a template and make changes to it. So we don't have to write this whole thing from scratch. Now notice that the mapping is listed in alphabetical order. And I'm going to delete everything from our console. Then we're going to copy and paste this entire mapping to the console here. Next, what I'm going to do is I'm going to remove the test index along with its opening bracket and closing bracket. Okay. Now, I've added here the optimal mapping we worked out earlier. So the first string field we're going to work on is country of origin. So let's scroll down to it. Now, for the string field country of origin, we want to set the field type to text and keyword. And as suspected, this field was automatically mapped twice as both types. So we'll leave the mapping as is. Now, for the fields description and name, we want to set the type to text only. So let's go to the description. You'll see that it has been mapped twice. So we're going to leave type as text and delete the keyword multi field here. All right. Now we're going to do the same thing for the field name. All right. Now, we also want the field produce type to be set as keyword only. So let's scroll down to produce type, and we're going to set the type to keyword and get rid of the rest. Okay. Next, we know that we won't perform queries or aggregations on the field botanical name or the vendor details object. So let's go to the botanical field or botanical name field. Now it's mapped twice as text and keyword, meaning that if we were to map it this way, the inverted index and the doc values will be created for this field. Well, that's a huge waste since we're not using this field at all. So to avoid that, we'll delete text and keyword here. Then we're going to add a parameter called enabled and set it to false. And this will prevent the inverted index or doc values from being created for this field, right? Now let's move down to vendor details object. Now this object contains multiple text fields. And since we're not using these objects, there's no sense in creating inverted index or doc values for multiple fields in this object. So we're going to delete everything inside this object and add a parameter called enabled and set it to false. Okay. So just in case I went over that too fast, I included the optimized mapping in the repo for your reference. So what we just did is we defined optimal mapping for all of our desired features except for the one marked with X here. Now I'm saving this for later, so don't worry about that for now. Now next, we're going to create a new index with the optimized mapping we just created. So here we have optimized mapping. And just above the mapping, we're going to add put followed by name of the new index, which we'll name produce index. And since the optimized mapping is already in the console, I'm just going to copy the first line, paste it here. And I'm being overly picky, but the indentation of this request seems a little off. So click on this wrench tool here, click on auto indent, and it should make it look nice and pretty for you here. All right. So let's select this request and send. All right. Oh, whoops. Root mapping, insert quantity type. Oh, what happened here? Give me 1 second. enabled false. What did I do? I must have made some mistakes while I was doing this. So actually, I'm just going to copy and paste the request that I sent, the request that I included in the repo here. Sorry about that, guys. And send it. All right, perfect. Now, it seems like that worked. But just to make sure everything has been mapped correctly, let's check the mapping of the produce index. Okay, so the request that we're going to send is get mapping of produce index. So let's copy and paste that here. Make sure to select and send. All right. Now, compared to the dynamic mapping, our optimized mapping looks more simple and concise, right? And you'll see that our optimized mapping satisfies the requirements that are marked with green check marks, right? So just by defining our own mapping, we prevented unnecessary inverted index and dog values from being created, which saved a lot of disk space. And the type of each field has been customized to serve specific client requests. So we also optimize the performance of Elasticsearch. Okay, so we just created a new index with the optimized mapping, but there are no documents in there yet. So the next step is to index your data set into the new index. And for simplicity's sake, I'm only indexing 2 documents here. So notice that the first document is identical to the document we've been working with. So let's copy and paste that here. And send. All right, looks like that worked. Now, the second document is about mangoes, and its fields are almost identical to the first one, except that it has an extra field called organic set to true. Now, we didn't have this field when we created mapping for our index, so this is a new field. So let's copy and paste this into the console. Make sure to select and send. All right, so it looks like it worked. Then we'll check the mapping of the index to see what happens. So let's copy and paste this request here, get mapping of produce index, and send. And you'll see that Elasticsearch dynamically added the new field organic to the mapping. And this makes sense because we can add new fields to the mapping. We just can't change the mapping of an existing field. Okay. So say you added the rest of this huge data set to the produce index, then your client comes back and asks to run only a full text search on the field botanical name. Well, that's a bit of a dilemma because we disabled the field botanical name when we created this index. So remember, we can't change the mapping of an existing field. If you do need to make changes to the existing field type, you have to create a new index with the latest mapping, then reindex all documents into the new index. So the first thing that we're going to do is to create a new index with the mapping that we want. So this is very similar to what we just did with the test index and produce index. So first, I'm going to delete everything in the console. Then copy and paste the mapping of the produce index. Now, we'll remove produce index here and the opening bracket and also its closing bracket. So hopefully I'll do a better job this time. Okay. And then we're going to go to the botanical name field and we'll set the type as text. And then we're going to delete the enable parameter here. Okay. Then just above the mapping, all right, we will write put followed by name of the new index with the latest mapping. All right. Then I'm going to auto indent everything here to make it nice and pretty. Oh my God, please work. All right, I'm going to select and send. Yes, it worked. All right. So let's check the mapping just to make sure everything worked. So the request you're going to send is get mapping of produce v2 index. So let's copy and paste that here. Make sure to select and send. Okay. So you'll see that the field botanical name has been now changed to text. Okay, so we just create a new index with the desired mapping. The next step is I can't talk. The next step is to reindex the data from produce index to the produce v2 index. So the request for reindexing looks like this. So it's post followed by reindex. Then we specify the source, which is the original index that contains a data set that we want to move over. Then we specify the destination, which is a new index that contains the latest mapping that we want. So let's copy and paste that into the console. Make sure to select and send. Now, if everything is successful, you should see a response like this. So this essentially moves data from produce index to the produce v2 index with a new mapping. And the total shows you the number of documents that you've reindexed. And 2 makes sense because we only had 2 documents in our original index. So from this point on, you can send all requests to the produce v2 index. All right. So we have one last feature to work on. So our client wants to be able to get the summary of monthly expense. And you've seen these diagrams before. So this requires splitting the data into monthly buckets, then adding up the total of each document in the bucket. So the problem is that our documents don't have a field called total. However, we do have fields called quantity and unit price. So to get the total for each document, we need to multiply the values of field quantity by unit price, then add up the total of all documents in each bucket, and this will yield the monthly expense. So at this point, you'll be thinking, all right, well, somehow we'll have to calculate the total and store this in a new field called total. Then we'll add this field to the existing documents, then run the sum aggregation on this field. But this can get kind of hairy because it involves adding a new field to existing documents in your index. And this requires reindexing your data and starting all over again. But there is a new feature that recently came out that helps you get around this issue, and it's called a runtime field. So runtime is that moment in time when Elasticsearch is executing your requests. And during runtime, you can actually create a temporary field and calculate a value within it so that this field can be used to run whatever request that was sent during runtime. So you might be sitting there thinking, what the heck is she talking about? So let's break this down. So for our last feature, the missing ingredient is the field total. And you must calculate the total by multiplying quantity by unit price. Now, right now, the field total doesn't exist in our data set, so we can't aggregate on this field. So what we're going to do is we're going to create a runtime field called total and add it to the mapping of the existing index. Now, this runtime field is only going to get created when a user runs a request against this field. So here what we're saying, hey, I want to add something to our mapping, and we are adding a runtime field, which we'll name total. Now, when a user sends a request against the field total, Elasticsearch will know to create this runtime field. Now, we know that the total will contain decimal points, so we're going to set this type as double. Then, in the script, we're writing out the formula to calculate the total. So what this script is saying is for every document, multiply the value of the field unit price by the value of the field quantity. So let's copy and paste that here. Make sure to select and send. All right, so it looks like the runtime field was added to the mapping. Now let's just check the mapping of produce V2 just to make sure everything was mapped correctly. All right, now you'll see that the runtime field has been added to the mapping here. Now remember, our index documents do not have a field total, but by adding a runtime field to our mapping, we're leaving some instructions for Elasticsearch. So here we're saying, hey, if you ever receive a request to be ran against the field total, create a runtime field called total for each document and calculate its value by running this script. Then run the request on the field total and send the results back to the user. So let's put this to the test. So scroll down to next step. Okay, so we are going to send the following request to perform a sum aggregation on the runtime field total. Now note that I'm not calculating the monthly expense here. I'm just sending a simple aggregation request to show you how the runtime field works. So this request is saying, get search results from produce index. I'm interested in the aggregations results only, so don't bother sending me the hits. And my aggregations request is named total expense. I want you to run a sum aggregation on the field total of all documents that exist in our index. So let's copy and paste that into the console. Make sure to select and send. And we're going to scroll down to the aggregations report, which we name total expense. And it'll give you the sum of the field total of all documents in our index. Okay, so let's talk about what just happened behind the scenes. So this request asks you to run a sum aggregation on the field total, and Elasticsearch will see this and refer to the mapping. And then it'll go, so this request is supposed to run against the field total. All right, so I'm going to create a temporary runtime field called total. Then run this script to calculate the total for each document. Then run the aggregation on the field total and send back the results. Now, what's really cool is that runtime is created and calculated when the request is being executed. And it's not indexed, so it doesn't take up disk space. And we also didn't have to re-index in order to add a new field to existing documents. And there are a lot of cool things that you could do with runtime fields. So if you're interested in learning more about it, I've included the blog here. Okay, so that's all I've got for you today. We covered a lot, but this is only the tip of the iceberg for a lot of things that you could do with mapping. And my hope is that you now have the basic knowledge to explore more on your own. So I'm going to turn it over to Faith for some announcements while I look over some of the questions that you guys asked during the session. Faith? Oh.
Oh, sorry. Okay, now I'm here. Sorry about that, folks. Not my day with technology. So really quickly, I wanted to highlight for everybody our virtual user group. So this is where we post all of our upcoming meetups and events and live streams. It's also where you can find more information and more sessions should they be added to this series as we move forward. So I've dropped a link to that group in the chat, and I encourage you to join so that you can stay up to date on all of our upcoming events. Additionally, I would also recommend subscribing to our YouTube channel if you haven't already. We go live on the channel very regularly. We currently have a live stream series that's happening every Tuesday. It's a Work With Me and AMA series with varying topics. So this coming Tuesday, we will have a live stream with Steve Gordon, who is an elastician who's pretty involved in the .NET community, and he's going to be streaming while working on a .NET project. So we're super excited for that upcoming, and you can be sure to stay on top of the latest live streams by subscribing to our channel. I also want to mention to you, as we wait a second for Lisa here, is our Elastic Contributor Program. So the Elastic Contributor Program allows participants to earn points for contributing in many different ways to the community. For example, if you commit code to one of our public repos, you have the opportunity to earn points through the program. If you speak at a meetup like Lisa has done today, you can earn points through the program. If you write an article, there are various methods through which that you can earn points in this program, and it's a great way to get recognized for the work that you're doing in our community. I will pull a link and drop that for you shortly. And I'll also hand things back over to Lisa as I look for that link. Lisa, do you think that we have time today to answer any of the questions that we got in?
Ooh, okay. So we're like at the top of the hour, but I do have a list of questions here. So the first thing, I could answer one, will there be a part 6 of this workshop? And the answer is yes. And I'm going to be hosting part 6 in the upcoming months. So as Faith mentioned, the link that you see here, if you sign up for this chapter, you'll be able to get a notification on the part 6 workshop that's coming up. And for the rest of the questions, what I'm going to do is, so you see this part 5 repo here. I'm going to answer your questions at the end of this GitHub repo for you. So be sure to check that out. And then I think one last thing that I wanted to mention. So if you are playing with Elasticsearch and Kibana and run into problems or have any questions, discussion forum is a great place to get your questions answered. So we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your questions here. And last but not least, I often blog about Elasticsearch. So if you prefer to learn by reading instead, be sure to check out my blog. All right, so that's a wrap for me. So thank you so much for coming, and we'll see you very soon.
Awesome. Thank you, Lisa. Bye, everybody.